Hello everyone, I am Dr. Arun Sharma. In this video, I will explain about the band gap. The band gap is the term which is generally used in solid state physics and chemistry. Band gap refers to the energy difference between the top of the valence band and the bottom of the conduction band. A material with a large band gap is an insulator. So, you can easily identify the insulator, conductors and semiconductors because of their band gap. So, the energy gap, that is the band gap between the two orbits, is given by this equation. Delta E, that is the energy difference, is equal to the energy of the final orbit minus energy of the initial orbit, EF minus EI. EF is the energy of the final orbit for the orbital NF, and EI is the energy of the initial orbit, that is NI. In case of absorption spectrum, delta E is positive, but in case of emission spectrum, the delta E is negative. Delta E, the formula for delta E is given here, that is RH Rydberg constant multiplied by 1 upon Ni square minus 1 upon Nf square, and in terms of joules it is 2.18 into 10 to the power minus 18 multiplied by 1 upon Ni square minus 1 upon Nf square. So this is the formula for the calculation of the energy difference between the final orbit and the initial orbit. Frequency associated with the absorption and emission of the photon. As we know from the Planck's energy frequency relationship, frequency is associated with the energy by this expression, that means mu is equal to delta E upon h, where h is the Planck's constant. As I previously calculated the value of delta E, that is the energy difference between the final orbit and the initial orbit, and put this value, we get finally 3.29 into 10 to the power 15 into 1 upon Ni square minus 1 upon Nf square. As we know that the wave number is the inversely proportional to the wavelength, and the wavelength we can calculate by the if we know the velocity and frequency, so finally we get mu bar is equal to mu upon c, and the formula for the c, where c is the velocity of light, that is 3 into 10 to the power meter per second. Now put the value of mu, that is the frequency, you will get finally 1.09677 into 10 to the power 7 multiplied by 1 upon Ni square minus 1 upon Nf square meter inverse. So this is the formula for the wave number, and it is the reciprocal of wavelength. So you can easily calculate the value of wavelength by the inverse of wave number. Please subscribe this channel. Thank you very much for watching this video. If you have any problems, please contact to me. Thank you very much.